There are 5 basic types of reactions: combination, also known as synthesis, decomposition, single replacement, double replacement, and combustion. Each of these types of reactions have key elements that separate them from one another and make them unique. Let's start with combination reactions. Like the word implies, chemicals will combine into some larger chemical. Here are some examples. Magnesium and iodine combine to make magnesium iodide. Aluminum and oxygen combine to make aluminum oxide. Notice these equations have also been balanced. Let's look at the next type of reaction. Decomposition reactions break apart. Zinc carbonate decomposes when heat is added into zinc oxide and carbon dioxide. Sometimes the actual word heat is used in the equation. Magnesium hydroxide decomposes into magnesium oxide and water. The triangle means heat. In a single replacement reaction, a single metal or halogen will switch places with a metal or halogen that is in a bond. Then you get a Repla single cement, obvi. Zinc and hydrochloric acid create zinc chloride and hydrogen gas. The lonely zinc and hydrogen are the cations, and they will switch places so that zinc ends up with chlorine and hydrogen ends up alone. Bromine and potassium iodide react to make potassium bromide and iodine. In this case, the halogens, which are the anions, are switched. More reactive metals will replace less reactive metals. So, look at the activity series of metals to see which ones will actually react. The single metal must be higher on the chart than the one in the compound that it wants to replace. So zinc can replace hydrogen, like the previous example, because it's higher up on the list than hydrogen. In double replacement reactions, there are 2 compounds that will swap cations. Then you get replicable cement. Whatever. They're pretty easy to spot because you see 2 ionic compounds in the beginning of the equation, and that's often the only thing they can do. They've got to switch places. Sodium hydroxide and perchloric acid make HOH, which, by the way, is water. And it also makes sodium perchlorate. The sodium and the hydrogen have switched places. Copper 2 chloride and hydrogen sulfide react to make copper sulfide and hydrochloric acid. Again, the 2 cations, copper and hydrogen, switch places. Combustion is usually obvious because of, well, a fire, a pop, or an explosion when you see the reaction. But on paper, you can tell because oxygen is present with some kind of hydrocarbon in the reaction. A hydrocarbon will have hydrogen and carbon. I love it when science just makes sense. Combustion has consistent elements. A hydrocarbon, oxygen, carbon dioxide is made, and water is made. Every time. See? Hydrocarbon, oxygen, carbon dioxide, and water. Those are key to combustion reactions. Let's focus a bit more on the kinds of reactions that happen in solution, aqueous reactions. When you mix 2 aqueous solutions together, sometimes you see a precipitate forming, and sometimes you don't. If a precipitate forms and you let all the liquid evaporate, you'll find that it's actually a solid. Use either an S or a down arrow as the descriptor for precipitate. The interesting thing about these kinds of reactions is that not every atom is really involved in the reaction. The reality is, since we're using solutions, the chemicals we start with are actually broken apart into ions. When they're mixed together, only some of those ions react. The other guys are still just floating around and watching the show. We call them spectators because of that. Sometimes none of the ions react. You can consult a solubility chart to see if any ions will form an insoluble, aka solid, compound. In order to see which ions are actually part of the reaction, chemists, and you, can write complete ionic equations, or even simpler, net ionic equations. Break anything that is soluble or aqueous into ions. Don't break up solids, liquids, or gases. That includes the down arrow. Copper chloride has 1 copper ion and 2 chlorine ions. Hydrogen sulfide has 2 hydrogen ions and 1 sulfide ion. Copper sulfide stays together because it's the solid in the precipitate. And hydrochloric acid has 2 hydrogen ions and 2 chlorine ions in this balanced equation. This is a complete ionic equation. But it's a horrible freaking mess, so let's clean it up and make the net ionic equation. Notice the spectator ions that are the same on both the reactants and product side of this equation? We can cross those out. Goodbye chlorine, goodbye hydrogen. Ah, much nicer. The net ionic equation only shows the ions that actually form the precipitate in the reaction. Happy studying!